So in the previous videos showed you what the application is and how it all starts off. Now what we're going to do is dive into code that I generate to be consumed by the React system to visualize the application. The way this works, and remembering funky green stuff equals a function, we're creating a function that will read this and then execute and build the whole area, and then for each bit inside we'll call other smaller functions to build up the parts. So how this works is we start off on the outside as usual with a plain old div called the app. Then it fires off the first one, which is CSS baseline. CSS baseline comes from a third-party library I use called Material UI, which is my go-to library for visualizations with React. Another one a lot of people have heard of is Bootstrap. It just so happens it's the one I tend to pick for most of my commercial React projects. And what CSS baseline does, even though it looks like it's HTML element, it's not. It's a function, and it goes off and sets up all the CSS and gets it working across different browsers. So it just sets the system up. Then the next thing is Apollo Provider, which we create. Comes in from an external system, and we create something called an Apollo client. And Apollo is a way of the web browser talking to a back-end server and asking for information, and we fire this function off and we insert an object into it, and this object will then be available to all the other functions that nest underneath it. It's just one of the features of JavaScript called a closure. If a function executes inside of another function, the function that's inside can see the things on the outside. And this is just a way of us providing this Apollo connection to the back end for everything that lives inside it. I want to just give you a quick taster of what GraphQL is. So this attaches to our Apollo server, and this is our Apollo server, and we can ask questions of our Apollo server. So for example, here we've asked a question called show us the world. Give us a list of countries with their IDs, names, ISO codes, and their outline. And over here you can see the result. And if you remember from the first video, we said we want to draw a shape of the country. We just leave lots of numbers to work out the points of the shape. So here we have Afghanistan's shape, Albania, Algeria, so on and so forth. And we can ask lots of different questions of the server. Just pop us back. So that's a quick overview of GraphQL. We'll be going much deeper into GraphQL in the client, plus also how I build a GraphQL server using some interesting techniques and caching to make a highly performant server. So that's the Apollo bit. Just sets it all up and makes it available to the rest of the app. Then we have a router, which comes from React, and the router basically says, if I'm given this, what should I display in here? And basically it says switch, and if the root up here matches this, so if it's got the word country in it followed by some text, it will pop a later date into a variable called country ID, followed by some text called city, followed by another variable that will pop into city ID. If it matches that pattern, draw the city page. If it matches this pattern, draw the state page. And the patterns get simpler and simpler until we get down to this pattern here, which says world. So it's got /world in it. We'll draw the world page, and the world page is everything inside the app here. One of the rules I have, other than naming, is I collect my data all at the page level. So the function with the word page in it goes and gathers all the data necessary for all the components underneath, marshals all that data, and then distributes it out to the different components so that they can visualize themselves. And we'll just take a look at the world page. CPV, And here we have our world page. At the top we import lots of other things, but again it's basically a 50-line function. And I'm going to go into a bit of detail how this works and how this works with functional programming inside of React. And this is very, very different to declarative programming, C#, anything object orientated. JavaScript's normally we call a face palmer language because you spend the first year with your face in the palm of your hands going, what the hell? Well, I'm afraid this takes it to the next level. But I'm going to go through nice and slowly and gently and explain what's going on. So, we create a function here called world page, which works out how to visualize this whole page, and we export it back out so the React system knows when it sees that funky green stuff with the word world page in it, execute this function and draw something on the screen. Okay, how all these functions work is you set them up and then you return something, and the return looks a bit like HTML, but it's a HTML style representation of functions. So the outside one here is called box, which comes from my Material UI system, which is basically just a div, but which allows me to switch overflow on and off. And then yes, now we need to start explaining React. This is a little bit tricky to explain. Writing code like this becomes second nature to you, but when you have to explain it to people, you realise it's a bit crazy. I've just spent the last 2 years working on a commercial Vue project, and Vue and Angular do this very differently. They have directives that much more explicitly state what we're doing. However, in the world of functional programming, I shall explain what this madness means. Basically it says, if show globe, do this, otherwise do nothing. Okay, so how does that work? These two curly brackets here mean evaluate what's going on inside and return something. JavaScript is a short-circuited language, so it's an if statement, if this and this. If this is false, it doesn't bother evaluating this. If this is true, it will evaluate this to see if it's true or false. So this is if show equals globe, then these two curved brackets here mean convert what's inside here into a function, execute those functions and return something that's going to generate the screen. So if show equals globe, put this piece of code in, otherwise do nothing. And if show equals globe, here we have globe, put it in a button, so we've got a div down the bottom right hand side, absolute bottom, and when we click, so on click, handle rotation, which is a function that we've defined here, so when you click this it does something. I'll just go back to the data, so it's now not equal to globe, now there's no button. Then we do page navigation, which is this bit up here, it's common to a lot of pages, and show and overlay. Show are these things, show the data, the map, the globe, overlay, none or terrorism, and it gets those from there. And then underneath here we have a container and we fill it with something, and the thing is a constant that we've created, a variable that we've created up here. So let me just go through the setup of this. Okay, Again, some more difficult concepts. The first one is called hooks. Now, inside the world of React, there are special functions, and they always start with the word use, and React will do some special things with these functions. When you call that function inside one of these functions, if at any later date this function returns a different value for some reason, it will then re-execute the outer function to redisplay everything inside. Sounds counterintuitive, very fast, works very well. So what we've got here is a state. So we're holding some state, some information, and this says use the state, start with false, and bring it out and pop it into a variable called enable rotation. And what's happening here is this function's returning an array, and the common pattern is the first item in the array is the value, and the second item in the array is a function that would update that value, because React needs a way of knowing if this function should return something different. So we fire off this function to set that value. Because it's inside one of these hooks, React will then re-render the world page and draw something different. I'll just show you how that works. So we're in globe and rotation is false. Click on it and rotation is true, and it does something. Click on it again and rotation is false. So this sets up the state. Then we've got two more hooks that I've written. Use query show, which uses the query string and pulls out the show information, and use query overlay, which pulls out the overlay information. And that puts it into two variables. We are never going to update them, so we can use a slightly different pattern and just bring out the variables. I'll just show you how simple these functions are. Use query show. Basically, it's a use query, another hook that I've written. And basically, it says if this function fire off this function, get the query. From the query, get the part that equals show, and return it in uppercase. And remember, if this function would give a different result, this one gets refired, and this one gets refired. And then we'll just dig into that function. So again, we've got use location, and that comes from React Router. So that function will give a different value if any of this changes. And then we've got some very terse code. This works, and basically it says use the location function here, fire it off, and return the search value. Pop that through a standard URL parameters and return that out. Don't actually like that. That's not how I would like to write that. I'd like to write that differently. I would write that like this. Okay. And then we take the current location. So I would write it like this, and I would write use location brings me back my current location. Anytime anything outside of this system changes and this function gives back something different, this will get refired. And then we say from our current location, bring us back the search part, anything after the question mark, and turn that into a URL search params object that we can use to query. Now, writing code like this is much easier to read than the initial example, and don't be worried about writing code like this and creating extra variables, because the JavaScript engine will optimize all of this and make very efficient machine code that runs very quickly. So you don't need to write terse single line stuff to get the web application to run faster. It's much better to leave it explicit like this, so people coming on behind you can understand what it is that you're doing. So Here's our world page. We've got our show and our overlay. And then we say if overlay equals terrorism. Again, this is more functional programming. We tend not to like to use ifs too much. We tend to use tertiaries. So I'm trying my hardest to use tertiaries. So if overlay equals terrorism, put that into there. Otherwise, put that into there. And these are our queries. And it's just different queries bringing back different amounts of information. So if it's terrorism, and we've got terrorism switched on, not only do we need to bring back all the names, but we need to bring back the numbers. But if terrorism's switched off, there's no point in asking for all that extra data. Then what happens, it goes into another hook. So we pass this value into this hook, and this returns an object which we extract three things from: loading, error, and data. The first time this function runs, it brings back something that's loading, null and null. And we come down to here and it says if loading, just return a paragraph that says loading. In a proper app we'd do something different, we'd have something more interesting there rather than just the words loading, but this is just a proof of concept. So it shows the word loading and it finishes. What happens is something deep inside the machine gets the information from the back end and then tells the React system that this function will now return a different value. So React then fires this off, fires all these things off again. Don't worry about that. These are all memorized. So because they're not changing the value that they bring back, they run very, very quickly. Then the second time this runs, loading is null, error, fingers crossed, is null, and data has got something in it. So it skips over these two bits, and then we say data, and this is destructuring. What we're saying here is we've got an object called data, and we want to pull out two things: the countries and the markers. So that sells up a variable, and then we say if show equals map, we'd like the map component, and we pass it the countries and the markers. If show equals globe, we'd like the globe component, countries, markers, and whether or not enable rotation is on or off. And then lastly, the one we've got here, world data, just pass in the countries, because there's no markers on this, if we just have a list of countries. Set up a function called handle rotation, and all that happens is when you click handle rotation, it gets the current value of rotation, sets it to the opposite one, and saves that.